So let's look at the polynomial that you see right here, okay? This is a polynomial that's in standard form. It's not factored, okay? So what can I tell from it? What's the degree of this polynomial? 4, okay? What is the leading coefficient? Leading coefficient is 1. Okay, what is the end behavior of this? What does it look like in terms of show of hands or arrows? What does this look like? It's going to look like this, okay? So it's going to go up on both ends. Mathematically, the way we write that, as x goes to negative infinity, where do the y values go? Positive infinity, okay? As x goes to positive infinity, where do the y values go? Positive infinity. They both go up, okay? So that's the end behavior of this graph. What is the y-intercept? Yeah, so if you plug in a 0 here, pretty easy math to see that the y-intercept is 0, negative 36. Okay, that's pretty easy to see from standard form. Okay, you plug in x equals 0, 0, negative 36 is the y-intercept. Now, if I was trying to check and see if I could factor this, one of the things I would say, like, are all the coefficients positive? No. So I know that I can't just say my roots are all negative. So that one doesn't help me. What happens when I add the coefficients? What's 9 plus 1? Yes. Yeah. No, if it's in standard form like this, it's the degree is whatever that exponent is. The coefficient is the number that's in front of it. Okay. Now it's different here. So in this one, the leading coefficient is 1. Here the leading coefficient is 1 times 1 times 1. And the degree is 1 plus 2 plus 1. Mm-hmm. No, you look at the fourth degree is my highest term. The number in front of it is 1. If this had been 2x to the fourth, the leading coefficient would be 2. If it's in standard form versus if it's in factored form. Okay. So what's the sum of the coefficients? 1 plus 9 is what? 10. 10 plus 23 is 33. 33 plus 3 is 36 minus 36 is. So what do I know from this? The sum of the coefficients is 0, so I know that x equal 1 is a root, or x minus 1 is a factor. So if I had to work on this problem, that's where I would start. I would start with 1, okay? What would be the possible rational roots? It'd be the factors of what? What are all the possible rational roots here? This is the homework that I went around and I just checked, okay, that you guys are done. What are all the possible rational roots of this polynomial? Plus or minus the factors of what? 36 divided by the plus or minus the factors of 1, okay? So really that comes down to being just the factors of what? 36. So the possible roots are plus or minus 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. So that's 36. These are all the possible rational roots, okay? So that would be all the possible ones that I could try to see if they work on this this polynomial, okay? Now, let's take a look. That was when it was in standard form. This is the same thing in factored form. How do I get the degree when I'm looking at this? Right, so this gives me an x, that gives me an x squared, that gives me an x. So when I add those together, this degree is 4, okay? How do I get the leading coefficient here? There's a 1 in front of this x, a 1 in front of this x, and a 1 in front of this x. 1 times 1 times 1 is 1, okay? So the end behavior, same thing that we just saw. This is the same exact problem. It's just in 2 different forms. So the end behavior is going to be the same. As I go to the left, my graph goes up. As I go to the right, my graph also goes up. The y-intercept. This is where it's a little bit harder to find the y-intercept. How do you find the y-intercept? You set x equal to what? Here. When you set x equal to 0, it's pretty easy in this first equation. When I set x equal to 0, I just get 36. I got to do a little bit more math in this lower equation. When I set x equal to 0 here, I'm going to get what? Negative 1 times 3 squared times 4. That is going to be what? Negative 9 times 4, which is negative 36. So I should get the same answer, 0, negative 36. Is that what I had before? Yes, same thing. Okay. Now, what's easier in this one that I couldn't ask in the other one, what are the x-intercepts? This is where factored form really helps you. What are the x-intercepts or the roots or solutions? So 1, 0. What are the other ones? Yeah, negative 3, 0. Negative 4, 0. That's what factored form is really wonderful about finding the x-intercepts. Multiplicity. Do any of these roots occur more than once? Which one? Yeah, so I know that there is this is the way we always said it, there is a multiplicity of, how many times does it occur? Yeah, multiplicity of 2 at x equal negative 3, okay? So my behavior of my graph, what will it do at that point? What will the graph do first of all, at 1, 0, what will it do? It crosses. What does it do at negative 4, 0? Crosses. What does it do at negative 3, 0? It does not cross the axis, okay? So I'm putting all of that information together. So what I can tell is I know that I do not cross, so I don't cross the x-axis at negative 3, 0, and I know that I do cross at 1, 0 and negative 4, 0. Okay, so using the end behavior, using the roots, using the multiplicity, then I can be able to graph this polynomial. So let's work through a few examples now, putting all of this together. Okay, so these problems are long, but there's nothing new. You just got to stay focused on what we're doing. I want you to completely factor this guy and graph it. Okay, so first I have to list what are all the possible rational roots. So it's plus or minus the factors of what? Yeah, so plus or minus the factors of 24 divided by the factors of 1. Okay, you got to like that problem. Okay, that makes it a little bit easier. So this really is just the factors of what? 24. So plus or minus. So that's 1 times 24, 2 times 12, 3 times 8, 4 times 6, right? So that's my list. Now, before I go checking and start working these guys, I check my 2 shortcuts. What happens when you add all these coefficients up? Do you get to 0? You don't get to 0 because they're all positive numbers, but they're all positive numbers, so what does that tell me? The root is going to be negative, okay? So am I going to start with 1? No, I'm going to start with negative 1. So this list of 1, 2, 3, 4, 5, 6, 7, 8, 16 numbers really only boils down to 8 possibilities, okay? So just try the negative numbers. So let's start with negative 1. So negative 1, and let's just do 1, 9, 26, 24. So if I bring down the 1, that's negative 1 and 8. This is negative 8, and that is what? 18. And this is negative 18. I don't really even need to multiply those together, Adam. I know that this doesn't work, okay? So now I do what? Yeah, I just move on to negative 2. So I'm just marching down the negative numbers here. So if I bring down the 1, that's negative 2 and 7, negative 14 and 12, that's negative 24, ding, ding, ding. What does that tell me? Yeah, x equal negative 2 is a root. What is the factor? X plus 2. Okay, so once you've done all that work, make sure that you get that work correctly. X equal negative 2 is the solution or root or x-intercept. Those all mean the same thing. X plus 2 is the factor. Now, this started out being what degree? What degree, guys? Third degree. If I can factor out 1x plus 2, that takes that third degree down to a square or second degree. So now I should be able to factor it. So now what I have is I've got f of x, or is it p of x? What do we call it here? P of x. P of x equal x plus 2 times what? Yeah, x squared plus 7x plus 12. Now, in my goal to get this completely factored, what has to factor now? This guy right here. In order for that to happen, what do I need? Yeah, two numbers that do what? Yeah, multiply to 12 and add to 7. Okay? So what numbers will do that? Yeah, 4 and 3. And so this just becomes P of x equal x plus 2, x plus 4, x plus 3. Okay? That's the complete factorization of this problem. So that's the final answer here. P of x equal x plus 2, x plus 4, x plus 3. What are the x-intercepts? Yeah. Negative 3, 0, negative 4, 0, negative 2, 0. What will the graph do at each of those points? It will cross over the axis, okay? So now, that was getting it factored. Now let's graph this guy. So here's what we started with. I'm on the next page. When we factored it, we found that P of x is, what did we say, x plus 2, x plus 3, x plus 4, is that right? Is that right, guys? Okay, so what is the degree of this polynomial? Now, here, when you've got both of these side by side, where is it easier to determine the degree? This one or this one? Yeah, the first one, I just look at it, there's a 3, that's the highest degree term. But you could get it from here, I've got an x times an x times an x, it's third degree. What's the leading coefficient? 1. So third degree with a positive coefficient, what's the end behavior going to be on this guy? Yeah, so it's going to look like x cubed. It's going to go up on this side and down on this side. So that's going to be what? Negative infinity, infinity. What's the y-intercept here? It's right. Yeah, yeah. So here's the deal. The easiest place to get the y-intercept, if I've got both these forms, is just to copy down that number. So it's 0, 24. Okay, because if you plug in a 0, 0, 0, you get 24. If you plugged in zeros over here, you would have 2 times 3 times 4. That's what, 6 times 4 is still 24. Okay, but you got to do a little bit more math, more possibility of making a mistake. What are the x-intercepts? Yeah, negative 2, 0, negative 3, 0, negative 4, 0. Is there any multiplicity here? No. So I'm going to cross at each of these points. Okay. And there we go. So now let's go graph this guy. So my x-intercepts, negative 2, negative 3, and negative 4. Negative 2, negative 3, negative 4. And then my y-intercept was 0, 24. It's off my graph, so I'm just gonna put it right here and call that 0, 24. Okay, my graph didn't quite hold it, but we'll be good with that. So where does the graph start? It starts where? It starts down here. So is it possible to cross, 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 hit this, and where do I need to end up? I need to end up going up. So I got to start down here. So this graph has to do something like this. It has to go through that first point. It has to cross again, and then it has to do something like that. Okay. So that was the only possible thing, the shape that the graph could take. So if you get in a situation like this where your y-intercept is 24 and my graph doesn't quite cover it, like I said, we're not going for complete accuracy here, but just relabel that point 24. You're good to go. So again, there was nothing new here, okay? It was what we did the last time we were together, rational roots, but I tied it together with graphing. And so if you can look at standard form and factored form side by side, this one gives you the x-intercepts and the multiplicity. This one gives you the y-intercept pretty easy. Both of these can give you the degree and the leading coefficient, and then you just use what you know to graph it. Questions over this? Yes? You can't find the multiplicity in standard form. It has to be in factored form, because multiplicity, it would be a multiplicity if I saw something like that one being squared. Okay, so you have to get to factored form to determine the multiplicity. Okay. So our keys here to everything we just did. For any polynomial I give you, standard form, factored form. Okay. We got to be able to look at the degree, the leading coefficient, the y-intercept. Factored form is where I get the x-intercepts, the roots, the zeros, the solutions. Multiplicity also comes from factored form. And then rational roots theorem. That's where I figure out the possible rational roots with those two shortcuts to be able to factor it. And then once I get to a quadratic, I can factor that. And like I said, the big thing here is organization and not making mistakes. And that's easier said than done. Okay, let's look at this example. So this is a big one. This is like as hard as they get. I've got a fourth degree polynomial. Synthetic division is going to have to work how many times to get it down to a quadratic? Twice. I got to get two roots. Okay. So what are all the possible? The possibles are going to be plus or minus factors of what? Yeah, factors of 24 divided by the factors of what? 1. Okay. That makes it a little bit easier. Okay. So it's plus or minus the factors of 24. So plus or minus 1, 2, 3, 4, 6, 12, 24. And now let's talk about our shortcuts. Are all these coefficients positive? No. So that doesn't give me the shortcut of them all being negative. What happens when I add these together? 1 plus 1 is 2. 2 minus 10 is negative 8. Negative 8 minus 4 is negative 12. Negative 12 and 24 is not 0. Okay. So that doesn't give me the starting point that 1 is a root. Okay. So now where do I start? Well, yeah, so I can try. So what's the question? Are you looking a little confused? So if they add to 0, 1 is going to work. If they don't add to 0, then 1 is what? Not going to work. Okay, so normally I would start down this list with 1, negative 1, 2, negative 2. I can do 1, but I guarantee it's not going to work. So what will I do next? I'll just go to negative 1. So I'm just going to march down this list in order. So let's just see 1, 1, negative 10, negative 4, 24. So if I use a negative 1, this is negative 1, 0. 0 minus 10. 10 minus 4 is 6. Negative 6. That does not work, okay? So 1 and negative 1 don't work. Where do I go next? Let's go to 2. So 1, 1, negative 10, negative 4, 24. 1 times 2 is 2. Add that to 1 and get 3. 2 times 3 is 6. That gives me negative 4. 2 times negative 4. That gives me negative 12. 2 times negative 12, negative 24. And you should be happy when you get a 0. So what does this mean? X equal 2 is a root. What's the factor? X minus 2. So I know that X minus 2 is a factor. You want to get in the habit of writing that down because you may not have this little sidebar on the test. You've just done the work that says X minus 2 is a factor. So that's when I write down the factorization, that has to show up, okay? So now what do I do? Right, I got to get it to work again, okay? So, well, negative. So I just worked. 2 worked. What should I do again? Try 2 again. When it works one time, it doesn't mean it won't work again, because if you had a root of multiplicity, That means it's going to work how many more than one time. Okay, so before I can rule 2 out, let's try 2 again. But I don't try it from the beginning, I try it from where I left off. Okay, so let's try 2 again. With what? 1, 3, minus 4, minus 12. Okay, so if I do that, this is 1, this is 2, that's 5. 10 minus 4 is 6. 2 times 6 is 12. What does that mean? It what? It does work, right? This means that x equal 2 is a root, again, which means what? X minus 2 is a factor. So I got x minus 2 as a factor. So I just found that x minus 2 is a factor how many times? Twice. That means this root has multiplicity of what? 2. Okay. So I know now that this polynomial that I started with, so p of x, so this tells me that p of x is equal to what? What are the factors that I know? Yeah, I've got x minus 2, and what am I left with? X squared plus 5x plus 6, right? I got that from right here, okay? So what do I do with x squared plus 5x plus 6? Yeah, I need two numbers that do what? Yeah, so two numbers that multiply to, it's positive 6, right? Multiply to 6 and add to 5. What numbers do that? 2 and 3, okay? So this turns out this is p of x equal x minus 2. X minus 2. What do I do with this 2 and this 3? What does that do? What happens to this 2 and the 3? It's what? X plus 2, x plus 3. That's my complete factorization. X minus 2, x minus 2, x plus 2, x plus 3. Now an easier way to write this, you know, that's correct, but I also could write it like this. Instead of writing x minus 2 times x minus 2, that's x minus 2 squared, x plus 2, x plus 3. So that's the complete factorization. So let's write it side by side with the original. So p of x equal x minus 2 squared times x plus 2 times x plus 3. Now let's graph this guy. What's the degree? 4. What's the leading coefficient? 1. So what's this graph going to look like? It's going to go up on both ends. It's a touchdown. Okay, so that means the answer to both these questions is infinity. What's the y-intercept? It's 0, 24. What are the x-intercepts? Yeah, 2, 0, negative 2, 0, and negative 3, 0. Is there any multiplicity? Yeah, there's a multiplicity of, yeah, so multiplicity of 2 at x equal 2. So that means when I go to graph this guy, at 2, 0, I do not cross the axis. At all the other points, at negative 2, 0, at negative 2, 0 and negative 3, 0, I do cross the axis. My y-intercept is 0, 24. Okay. And this graph starts where? Up or down or what? Starts up because it's going to look like this. So is it possible then to cross, hit that one, bounce off and go back up. Yes. So your graph is going to do something like this. And again, it's not important to me. Like when it crossed here, it might have actually gone much further down. I don't really care about that. We could use a calculator to get more exact. But you've got the end behavior is correct, every x-intercept behavior is correct, and the y-intercept behavior is correct for this graph. All right. So there's one that follows here. What I'd like you guys work on this next one. Okay. So the next one just works through what I have. And this is like that. This is as bad and ugly and long as the problems get in this section. Fourth degree, factor completely, and then graph it. Okay.